Welcome, everybody, to our Cultural Data Sovereignty Workshop. My name is Jesse McKee. I'm the head of digital strategy at 221A, an organization that I've worked at full time for almost a decade now. So I'm glad to welcome you online, from wherever you're calling from. I caught a few of the intros as we're warming up, and we'll get to know more of you and your work as we have conversations throughout these workshops. I don't know, maybe we can begin just with territorial acknowledgement. So Andi, if you want to just switch the slide. Yeah, 221A. So where I'm calling from, we're headquartered at 825 Pacific Street in downtown Vancouver, which is situated between the burial grounds of the Semenchuks and the shores of the EI on the unceded Indigenous territories belonging to the Musqueams, Squamish, and Tsleil-Waututh nations. So at 221A, we recognize that the colony of British Columbia was created through organized dispossession and colonial violence. We seek to shift our organizational practices to work together with Indigenous people to end ongoing violence, dispossession, and displacement. So yeah, this is a data sovereignty workshop, but 221A is a pretty diverse organization. It's an image of one of our other workshops in the fall, which is a leather tanning kind of workshop, hide tanning and preparing skins in a garden that we operate in Chinatown that's co-developed with Squamish ethnobotanists and artist Toitsnat Siswais that's full of Indigenous plants to this region. So if you're in Chinatown, go visit that space as well, 271 Union Street. And there's an ongoing program there that's pretty incredible. And as we talk about data sovereignty too, I think, yeah, Eli, you brought it up earlier, but there's many examples as well of Indigenous data sovereignty projects here in British Columbia, across the country and internationally that we're inspired by and that we're in conversation with. And one of those projects here, at least in British Columbia, is called Chinook X. And we've been collaborating and learning from them since the beginning of our digital strategy work. And they're an interesting organization who's really working with Indigenous communities on traditional territories to think about what data sovereignty is, how to operate your own infrastructure, how to keep that information private and shareable between Indigenous communities only. And especially so, they're thinking for cultural data, but they're also working on green energy data because that's also very valuable. And it's also the data sovereignty is wrapped into energy sovereignty and also thinking through a whole life cycle of how data is produced and stored and created and shared for those nations. To have a look at Chinook X, there's lots of materials online about them as well. You can just switch the slide to why we're here today, the workshop overview. I think that's my slide, is that right? Yeah, we are going to look just briefly at what 221A is doing in the digital strategy space. We're going to look a little bit into the future about what we're trying to create and talk about fair data principles. Then we'll hand it over to Andi and Vincent from Hypha Worker Cooperative, and we'll talk about decentralized storage and what centralized solutions look like today and what we've learned from the GLAM sector from a couple of engagements and projects we've done over the past couple of months. We'll look at what the benefits of decentralized storage are for the GLAM sector, and then we'll look at a few case studies, which include a data trust for some choirs in the UK, and then a storage prototype that we've developed called the Node Archives that will operate out of 221A one day, eventually. Okay. So this is just kind of something to get us talking. Maybe it's just a good discussion point, but we will look at this a little bit closer later on during some case studies. But I think it's an important perspective that we need to talk about, and it's probably one of the main reasons we're having this workshop today. But as that advertisement for an exhibition, or as the sign says, all media is training data. So I don't know, does anybody want to respond to that, or does that raise any questions or comments from anybody?
That's one of the big discussions that we've had as we're trying to put together an archive of 50 years of creative work at the company I started 52 years ago. It's a performance-based company, and we had a large theater, so we saved everything. And now we're trying to figure out how do we make it a live archive as opposed to a dead one stuck in somebody's basement in boxes. And we would like to have every bit of our archive be a training data so that people can see how a small not-for-profit was started, how work was created, how they could take the work and use it for their own work. We'd like it to be available and useful to everybody. And it seems like that's a hard nut to crack.
Yeah, That's right. And yeah, just to answer on the comments specifically, yeah, this is about AI training. So that all training, how companies or how AI products are trained is generally by trawling the internet, trawling like a fish trawler, not trolling, but trawling and just picking up whatever they can find, whether they have the rights to it or not, and putting it into data sets and training their AI models on it. We believe there's other ways to do it, and it's just a good perspective to think about, especially since a lot of us in the GLAM sector who are involved in digital humanities over the past decade or so were really trained on providing open data, right? So that open data was a value, was a priority. But now something has shifted, and there's more at stake here. How we treat our data and how we digitize our physical media and where we keep it online is a question right now. And so it's hopefully we can give you a few footholds in these workshops to start thinking through some solutions. Everything's not ready because a lot of this still needs to be built to a better standard, to something that's more user-friendly. But I think we, as a sector, need to be involved in this conversation at a developmental level, because I think we have a lot of very important data, of course, but I think we also play a very important role socially and in terms of that trust. And we've been the keepers of information for many generations. And how we transition to this AI knowledge space, I think we can play a big role in starting to bridge public trust by demonstrating the kind of use cases and the kind of protocols that we want to see around this knowledge being shared in these models. Okay, Andi, you can switch to the next one. So we've been thinking about this for a while at 221A. So some of this work dates back to about 2019. We've been working on a digital strategy here. We launched that with a research cluster around the project called Blockchains and Cultural Padlocks. Nice to see Vicky Lemieux in the room. She's been here since the beginning as well with that project. And that looked at blockchain technology, which we'll talk about today. It's what underpins a lot of decentralized storage networks now. And for us, it was a way to look at information transparency, information ownership, and governance. And it was a technology that allowed for all three of those things. And as an organization that is thinking about infrastructural development, community benefit, it seemed like a major infrastructural turn that we should pay attention to. So we were supported really well by the Canada Council for the Arts over a couple of grants in the Digital Strategy Fund and then the Strategic Innovation Fund to do this work. And there's a report that came out in 2021 that looks at some of that early research from our research cluster. There's some longer form essays there from some of the writers and artists involved in that period. And it really gave us a direction to think as an organization, how do we work towards a digitally cooperative culture? And we're especially interested in the ideas of recommoning land, data, and objects in that space. So that's where we were in 2021. And then from 2022 to 2024, we tried to think about how do we implement this research and make it operational? How do we offer it to create sectoral change? How do we turn this research into like rubber hitting the road, essentially? So we spent a solid 2 years working with people across culture, civil society, and technology sectors to plan out some operational outputs. And what could that look like? Because we want to be there over that long period. So we wanted to make sure we had the right plans in place to do that. And now where we're at in 2025 is we're getting ready to pilot this, and we're trying to turn some of our work here at 825 and maybe some of our future projects at 221A into a fair data hub. And we'll get into what fair data means a little bit later, but essentially it's an ecosystem for community governed digital infrastructure. And we want to ensure that communities shape and benefit from technology development, especially AI. And just a rough digital mission that we're kicking the ball around with, so let us know how this sits with you, but we want to build infrastructure that puts communities in control of their digital future. So that's a tall order, but I think it's a mission that our institutions need to take on. And we'll talk more about what that looks like later on in the presentation. Andi, you could take us forward. Great. So essentially where 221A comes in is we were really curious to play a stewardship role or a super connector role in this ecosystem that's bubbling up around a data economy. So Rather, we could create software, we could create solutions, we could create advocacy, we could do all of those things, but doing them well individually takes a lot of work. But we think that our role might be a bit further upstream in helping those superconnectors come together to create the right ecosystem and to create the right kind of knowledge reproduction that comes out of that. So what we're thinking about is the economy around fair data and providing trained and like well attributed and credited and with rights respected kind of data to the AI economy is going to take a lot of things, but it's going to be a very big economy. For instance, I know here in Vancouver, our airport, YVR, they're very clever with their digital strategy, and they've created a digital twin of their airport. For several years now, they've been doing this, and they've had live sensors feeding back that digital twin information to the computer. So the computer understands what's happening in real life, and real life understands better what the computer is suggesting. And by looking in the mirror, the airport has achieved this efficiency that no other airport in North America seems to has achieved. And what that's done is it's given them the biggest data set about running an airport in the world. And so what they're able to do with that is create a marketplace for other airports to come and use an AI model they might build on that data that helps them run their airports more efficiently. And that business for YVR might be 5-6 times larger in value than the actual brick and mortar operations of an airport. Well, if you're early to the data economy like this and you're able to capture that value and able to bring it to the AI market, you're able to drive how that data is being used, what outcomes are coming from that data use, and you're also able to create a business model around that participation in that economy. So with that, we're thinking this fair data economy is made up of a couple pieces. So that includes next generation digital infrastructure, which we're talking about today, entrepreneurship and new business models. So we need to encourage experimentation in this space to figure out what's working and what's not working. We want to work directly with government and industry leadership to think about policy innovation and frameworks. And we want to think about how are our resources being well allocated to achieve these outcomes. So what do we mean when we say fair? Yeah, fair does just work as a fair trade, but it is an acronym actually that we're taking from Project Liberty, which is a project out of the US that's also interested in data rights. But fair for them is findable, accessible, interoperable, and reusable. So findable meaning your data is easily discoverable through clear documentation. Its persistent identifiers have long-term access, and there's rich metadata that enables contextualization. The data should be accessible, so clear protocols for access, authentication. Communities should maintain control over access conditions to their data, and the technical barriers to accessing should be minimized. And that happens over design and over time, we know that, but should be something that we strive for. It should be interoperable, our data, so the data uses are widely adopted and standards and formats are well used. The metadata is machine readable and standardized, and it's cross-platform compatible. And the data should be reusable. So there should be clear licenses for specific use terms. Detailed provenance information is maintained on that data, and the quality is documented and often verified. So these conditions don't exist in most use cases so far, but I think what we need to do in thinking about this fair data economy and as a sector is thinking upstream about how do we start to work with projects and protocols in this space that are going to be more likely to create these outcomes. And that's just comes through experience and trying things out and communicating and talking widely about what we're learning and what we're learning. Okay, Andi, if you could take us forward. Within that fair data economy would be cultural data, I would say, is one piece of that. But we play a pretty outsized role in that, I would say, because of that trust role that we play in society. So some of the findings that we've had from folks like the BC Museums Association, Canadian Museums Association, American Museums Association, is that in terms of public institutions, GLAMS are some of the most trusted institutions out there. Civic, federal, provincial, state governments Their trust is at about 30% across broad public. Mainstream media equally, their trust is at about 30% across the board. Whereas in the GLAM sector, it varies between who you're talking to, but somewhere between 60 to 80% of public trust GLAM institutions. With that trust, if we're able to identify the use cases that we believe will have the best social outcomes, we can start to demonstrate them and start to build those bridges and start to show people that, yes, you have every right to be suspicious of AI and you have to be concerned and you have to be critical. But here are some examples of what we're trying to do. And these are the values we're working from. And these are the outcomes we want to see from this kind of work. And I think the more that we can enter that conversation publicly, the better everybody off will be for it. So when we're talking about cultural data and its sovereignty, it's a governance framework, and that can vary depending on the scale of what needs governing, but it addresses how cultural organizations maintain authority and control over their digital assets and information, regardless of where that data physically resides. So that's a big issue within cloud storage, is that you think it's offsite, it's out of mind, it's easily accessible, but your rights, if you had your own hard drive. Decentralized storage, we'll talk about how that can start to remedy some of those pressures. And then data ownership and rights exist within a complex landscape of jurisdictional boundaries too. So data, this is what I mean by we need new business models and we need the policy framework as well. So data is trafficked around the world internationally pretty easily, but at the same time, there's specific rights that pertain to certain states and legal jurisdictions. It's a complex kind of landscape of boundaries. There's technical infrastructure you have to think about. Cultural traditions definitely inform how data sovereignty should be enacted. And it's about your organization's responsibilities and who your stakeholders are and the commitments that you have made to them. So these are all the things you have to think about in terms of your organization or your cultural or your culture's data and what sovereignty means for it. And sovereignty in this case might not just mean from a level of government per se, but it could also mean, I think we should start thinking about sovereignty in terms of the major big five internet players as well. So you can also think about your data as being sovereign from Google and Amazon and Microsoft. And there is value to that as well. So when we look at this overlapping space around cultural heritage, data storage in these jurisdictions, for cultural heritage, we're really thinking about what are those kind of key digital assets that are held by these organizations, and what are the knowledge systems that come into play that those digital assets come from and have lived within for many generations already. The data storage, so there's the physical question, physical location or cloud infrastructure, or is there a secret third option we might talk about later today? And then jurisdiction, so legal frameworks. So there's the law, and then there's also organizational governance and community governance around how certain cultural pieces are enacted. For instance, like I know a digital community in Europe that's made up of circus performers, and they've developed their own kind of framework around who has the right to perform certain circus acts, and that who has access to the information about those acts is then managed around those access protocols, depending on what you qualify for and who you have trained with and who you've been mentored by and how much time you have spent doing such and such. So all of these things that come into play as well, depending on what kind of cultural data you are dealing with. And when it comes to Indigenous cultural data, that is an even more complex question that touches on Indigenous cosmology and worldviews as well. And Chinook X speaks to that work very eloquently as well. Cultural data sovereignty and GLAMS. So there's a nice image of the Belkin Art Gallery at UBC. They have a great archive called the Image Bank Archive that was collected by two artists here in Vancouver throughout the 60s and 70s, Vincent and Michael Morris. But I think, yeah, it's a good that image. I put that in because it's a good reminder of how sovereignty can change and your perspective of it can change suddenly. On the bottom right corner, one of the items in the collection there, that's a piece of the Berlin Wall they collected while they were on a DAD scholarship. When the Berlin Wall fell, it's wrapped in barbed wire and in a champagne bucket with a bottle of Veuve Clicquot. So in the museum and looks after that in perpetuity as a reminder of that sudden change of sovereignty. But arts and cultural organizations must actively manage their data's physical location. So that's a big question too, when you go from local storage to cloud storage, what's gained and what's lost? What are those conditions? What are the access protocols? And what are the prevention strategies to maintain meaningful control over digital cultural heritage? So that's why Eli's done this course as well with the Filecoin Foundation, because there is a larger push, and I think there is that recognition of that trust and of our needs within the space to start moving with this technology. And there's a lot that can be learned on both sides. So I think if we're coming in at this and we don't feel like we're totally technically trained and oriented towards this stuff, don't be afraid, because the community on the other side I have found in the technology space so welcoming and curious and just supportive to work through challenges and find common problems that we both think need solving. So don't be shy if you don't know how to code. I do not, but I've been a digital strategist for several years now, and it's okay. Great. So why don't we hand it over to, I think, Andi and Vincent, you'll take it next to look at some of the work that we were doing over the summer.
Thanks, Jesse. So I'm going to talk a little bit more about the digital storage landscape specifically, but before I jump into that, I'll just do a quick introduction. So I'm a member owner at Hypha Worker Cooperative. We're a member-owned technical consultancy. We have members across Canada and one in the US. And along with Vincent, who you'll hear from in a few slides, we run the Co-Creation Lab, which is a practice area within the co-op that focuses on arts, culture, and decentralized tools. Similar to Jesse, I am not a coder, but I have a background in information sciences and have most recently worked in research and program management roles before I joined Hypha. Okay, so on to digital storage. As part of the Node Archive pilot project, which we're going to talk about in some detail towards the end of the presentation, we worked closely with 221A on this project, and along with 221A was a graduate research student who was part of blockchain at UBC, and an archivist. Her name is Reiko Plau. Too bad she can't be here today because she did some amazing work last summer surveying folks in the GLAM sector to set us up for creating a prototype for the Node Archive itself. And the survey went out and about 83 people answered it, who self-identified as working in the GLAM sector. And they were asked about their current digital storage perceptions and solutions and how they felt about using blockchain-based digital storages and solutions. And there's some interesting data, which we'll cover very lightly today. This slide is from that survey, and participants were asked about their current digital solutions. And as you can see, hopefully, although I imagine that it's quite small font, is the usual suspect. So Google Drive was the primary, and then I believe it was, and then personal drives is 27%. I just realized that maybe this is the wrong image. So it was a split between personal drives, so just the drive on your computer, and Google Drives, and then Dropbox, iCloud storage, and Teams-based or Microsoft storage came in third. So probably what you would expect. And maybe the one thing to note is that we didn't specifically ask about archival storage. This is just general digital storage. So what's wrong with the technical status quo? As a preface to this slide about centralized technology, I feel we're in a period of technological reckoning. It might just be me, but I think that for some people that work in the tech space, the cost of this sort of seamless, easy up in the cloud tools we've come to rely on are becoming increasingly apparent. It's not just up in the cloud. There actually is physical infrastructure that we use, and there are real people involved in this. And a fairly obvious example is the purchase of Twitter by Elon Musk. It turned from what people would consider a digital public square into a platform that now, for many of us, espouses a number of injustices and abuses, and is generally not particularly a lovely and public welcoming space. So you could compare this, like something that's centrally owned, to federated social media. You might have heard of something called Mastodon. This runs off of federated servers. So you join a particular server, and then those servers talk to each other. And if you don't like the server that you've joined, I belong to one that's called social.coop. It's a cooperatively run instance. But if I didn't like the way that the decisions they were making about who to block, for instance, I could actually just take my account and go someplace else. It's a little bit more complicated than that, but it is cool. And so unlike Twitter, where there's really no option, you just leave these things behind. So turning back to storage, what does this mean? What does the dependence on one vendor or platform mean? What are some of the other risks that are involved in centralized services? So cost is pretty obvious, and these were highlighted in the work that we did through the survey last summer as well. I'm pretty sure we're all familiar with the escalation of SaaS costs, software as a service costs, where you start out at one tier, then you've got more data, now you're paying more. That's a fairly typical path. Vendor dependence, which I touched on with my Elon Musk analogy. Security risks are also truly something that everybody should be considering. I think at this point, we've probably all been directly or indirectly affected by ransomware. I think one of the standout moments for me was last year when the Toronto Public Library was subject to a ransomware attack and was offline for 4 months. That was pretty epic. Or I know quite a few of you are out in BC, and the London drugs shut down for a week last year, similar thing. So this is the sort of thing that everybody's always, oh, it's not going to be me, it's not going to be my organization, but this is always an issue. It could actually happen to any of us. We've already talked a little bit about data sovereignty, as Jesse mentioned, but I think maybe one of the things to think about here is how the current tensions between Canada and the US and the way our infrastructure is actually arranged plays out. I think maybe some of the Buy Canada, I know that there's been some inquiries around where is your servers and data hosted? Can you support Canadian organizations when purchasing some of these hosting options? And just as an aside, Canadians have been subject to the US Patriot Act for many years, which basically forecloses some of our rights in terms of privacy when our data passes through the US. So these things are all assumed risks when using any of these cloud-based services. And lastly, there's environmental impacts of centralized storage options. This definitely is not something that goes away when we consider decentralized storage options. But so you're definitely important to be mindful that all of the options we're discussing have some environmental impacts. But the options we're going to talk about in the decentralized component, which we'll move to shortly, does give you more visibility. It's like you're unblackboxing those tools and you can have more control and see what it is you're using and get a better sense of your energy usage. All right, so let's zoom out from centralized storage to focus on what we mean by centralized. So this diagram comes from a 1964 Paul Barron article called Undistributed Communications Network. This is a little bit of information sciences history for you. So this report laid the groundwork for packet switching, which is actually what underpins how the internet functions. And it provided a blueprint for ARPANET, which was the early instantiation of the internet. I like this. Especially when you get into decentralized and distributed, there's definitely some overlap. It's not this neat trichotomy division, but I do think it's a really useful mental model for thinking about the different network topologies and the systems that we've got. So on the centralized side, there's a single server that's basically like the boss. It passes the data to the other computers. It does all of the work. You find this in client relationship management systems, some email servers, banking systems. In the middle column, the decentralized network, this displays a series of nodes that consists of servers and computers. These are typically spread out across various locations and they share control and power without a single central authority. So this is the system you find in blockchain, cryptocurrency, peer-to-peer networks, or if you're familiar with them, like community-based mesh networks or Wi-Fi networks. And then on the further side, the column C here, in this case, there's multiple independent nodes that work together to achieve a common goal. So a lot of SaaS software uses distributed networking. So this could be like cloud computing platforms like AWS, and that's Amazon services, which provide compute services, or CDNs or content delivery networks. These are servers that deliver web content based on users' location. So all of these are in use in some degree or other, but hopefully it's helpful to just have this as a mental model as we go forward. Okay, so now we're going to zoom back into the decentralized infrastructure piece. So as a way of framing sort of this generally, there's a popular narrative that you might have come across about the evolution of the internet. So this is like framing it as Web 1.10 to Web 3.0. So we'll go through that. So Web 1.1 was like the early days of the read-write web. This is like back in the GeoCities era, if anybody was around then. And then that we'd say gave rise, all these things really overlap. The read-write interactivity of Web 2 and the rise of social media. So now we're not just passive consumers, but we're participating in the creation of this content in a more widespread way. And so now some would say, although, as I said, these overlap, we're in the era of Web 3, which encompasses read-write and ownership of these networks. Of course, this is all messy and overlapping, but it might be useful to have some framing for how these aspects of the internet have evolved and where we're sitting now. Web 3 and its current blockchain connotations was popularized by Gavin Wood. He's one of the co-founders of Ethereum and Polkadot. Before it became very closely associated with blockchain, the term's actually been around since the 90s. Tim Berners-Lee came up with it, and it used to refer to the semantic web, which is where all data is machine readable, shareable, and reusable. But it got co-opted, some might say, by a blockchain, or reassigned its meaning. My colleague, Mai, wrote a really interesting article that talks a little bit about this. I'll share it in the chat after I'm finished talking. So today, Web3 is generally synonymous with protocols and platforms that involve blockchain and distributed ledger technology, including cryptocurrencies. So what are distributed ledger technologies, or D? This is the technological infrastructure and protocols that allow access, validation, and record updating across a network database. It's the infrastructure that underpins blockchains. These are governed by something called a consensus mechanism. You might have heard of something called proof of work or proof of stake. If not, I can go through those. You can let me know in the chat if you have no idea what I'm talking about, and I can provide definitions there. And the other thing to note about DLTs is that they most often have some sort of payment or monetization aspect of it, and this is where the cryptocurrency piece comes in. So DePIN, this is decentralized physical infrastructure, and this is the pieces that Jesse was alluding to earlier around having greater ownership over some of these infrastructural networks. So DePIN combines both a decentralized actual physical hardware and infrastructure, so like a server sitting in a room, with an incentivized component. So it's tied to a cryptocurrency where the participants in that network are able to gain tokens or earn money from their participation in the network. I was looking for some examples of like how this has been instantiated, and one of the interesting ones that I came up with, and I don't want to vouch for how widespread it is a company called Helium. It offers two products. So one is for Internet of Things. So this is like a network for your dishwasher and all the other devices that might or not be connected. And then the second product is for providing mobile internet and for phones and devices. And essentially what they say is that like you assign your additional data to their network, and then you're creating like what they call a people-owned hotspot and Wi-Fi networks. So you don't rely on your existing internet carrier. Instead, you're using this alternative networking infrastructure that then when you're contributing to the network and not just using it, you get something called HNT, which is their token, or you can earn USD. So that's just one example of DePIN. And then lastly, but not least, is peer-to-peer networks. So in peer-to-peer networks, these are all the computers and devices that are part of them are referred to as peers, hence the P2P. These peers are equal and they share and exchange workloads. There's no privileged peers, unlike in a distributed system, where there's usually one computer that is privileged. And there's no primary administrator device in the center of the network. So they're both distributed because they involve a number of computers, and decentralized in that they're all equal. This is to give you a grounding on what we're going to go into next. These things build on each other. I'm going to turn it over to Vincent, who can give a quick intro and then talk you through some storage protocols.
Hi, everyone. I'm Vincent. I'm a colleague of Andi, a technologist, artist, software developer, and a member of Hypha Worker Co-op. So I'll take us from, we were talking about infrastructure and zoom into the specificity of storage protocols. So I'll be giving an overview of the evolution of the decentralized storage protocols. So we can start with some initiatives that even predate blockchains. Before blockchains, there were systems that laid the groundwork for storage decentralized. A notable example is LOCKSS. And that's an acronym that stands for lots of copies keep stuff safe. And LOX is the open source system for digital preservation. And this network, it pioneered the concept of distributed preservation, and it did so by redundancy. So libraries would maintain copies of content published on the web, creating a resilient network that could survive individual server failures. Then next, there's MadeSafe. That was conceived in 2006, and it took decentralization further with its safe network. There's a lot of acronyms here, but that's secure access for everyone. The Safe network was described as the world's first autonomous data network, and it did so by introducing concepts of self-encryption and distributed hash tables. This created a data network where users could contribute storage resources. And so these systems that predate blockchains demonstrated the technical feasibility of decentralization. Then there's Protocol Labs. Protocol Labs created a whole ecosystem. And so before talking about these specific technologies, I'm going to give just a short intro to what is Protocol Labs. So it is an open source software research and development company. They're mostly known for creating IPFS, which stands for the Interplanetary File System. IPFS launched in 2015. It represented a fundamental shift in how we address and distribute data. And most of the time when we go on the internet, we type an address, and that URL, that address, points to a specific server. IPFS does it differently, where it uses content-based addressing. Instead of pointing to a space, you're identified by the content, similar to a digital fingerprint. These content identifiers, I'll refer to them as CIDs. And basically, this is what is meant when we will mention a few times in this presentation, the content-based addressing. Those CIDs, they enable the resilient, censorship-resistant web infrastructure. And I'll get into the details of how it does so later. And then came blockchains. And blockchains introduced a key element in this ecosystem, which is incentivization. This allowed for built-in economic incentives built into decentralized storage. So by coupling this economic paradigm with distributed system, blockchain-based storage protocols allowed to reward participants for providing resources. Which leads me to Filecoin. Filecoin, which was also launched by Protocol Labs, is one of these storage and retrieval projects, inserts this critical incentives layer. Filecoin creates a marketplace where the providers commit their hardware resources and in exchange earn a token for providing reliable storage. Proof allow for the verification of data. And then the protocol maintains a ledger with storage deals. So Protocol Labs is a whole ecosystem that has grown to develop technologies like libp2p, so that's a networking layer, library, IPLD, data model, and all of this creates a stack for decentralized applications. You can get a sense of the state of this landscape by looking at the storage protocol comparison document that this QR code links to. And so you can see on that document, like how these systems have different approaches. There's different trade-offs in terms of decentralization, performance, cost, the developer experience across all the variety of protocols. Andi, next slide, please. And so on that document, you'll see a list of protocols that I've added on the slide. This is a whole landscape that evolves from experimental projects to production-ready infrastructure. From peer-to-peer file sharing networks to sophisticated ecosystem, that landscape shows the variety of distributed systems with economic incentives and cryptographic proof. I'm not going to go through each of these, but I think it's interesting to break it down into distinct categories. There's overlap at times, but right? Just to give you a sense of maybe like the specialty of some of these protocols and networks. So some focus on permanent storage solutions. They claim permanence and this kind of formula where you pay once and store forever. There's these incentivized storage networks. So as I described, Filecoin, which you can have large scale storage marketplace with different incentives. Then there's a peer-to-peer content network, IPFS being most like the maybe most common, but there's also BitTorrent, IRO, and then there's others that really put the focus and attention on user sovereignty. So user-controlled data and file storage. And so there's all that to say that there's basically this ecosystem that is seeing very rapid evolution and makes the space really fascinating for its technical innovation, these kind of like experimentation on the economic side. There's shifting use case from NFT storage to AI data sets. And then there's a lot of interoperability efforts. And so projects are increasingly building bridges rather than operating as isolated systems. So I guess it's worth noting that some of these protocols are more in a prototyping phase, whereas others have reached a stable production.
Just had a question in the room here.
Yeah, I just, in your comparison, I wondered if you had a look at what the European Union is doing around data spaces at all. I noticed you have mentioned Solid, which is perhaps comparable, but yeah, any thoughts on the data spaces? So there is, within the European Union, there's quite a lot of work going on this concept of data spaces. And data space is, let's say, user-controlled computing environment. Technologically, it operates as a trusted execution environment that is controlled by the data owner, let's say, data, or at least data custodian. And so it's using trusted execution environments and relying a lot on mechanisms for authorizing access to the trusted execution environment. So you can look up, it'd be interesting for you to look up about data spaces. I don't want to take over here, but yeah, any thoughts on the use of trusted execution environments in relation to some of these other decentralized storage? Obviously, we're talking about storage, not necessarily computing environments, but just curious.
I think that's a very interesting point. As you mentioned, like this comparison table was mostly focused on storage and not on compute. But I think there's, as I just mentioned, these efforts of interoperability. And I could see an interesting interplay between the compute side of TEE or trusted execution environment and their storage component. Not familiar with the European data spaces, but definitely there is some potential for interconnection and working together these different components.
Yeah, okay. Thank you.
So we're going to get into more of the technical components of these storage systems. I broke it down into 4 different categories. And so the first one is data integrity mechanisms. And that takes us back to those CIDs. So those content identifiers. And as I mentioned, these identifiers are the equivalent of a unique fingerprint of some data content. And so they're generated through cryptographic hashing of the file content. And so any changes to that file will change its identifier. And so this enables very easy verification that the data hasn't been tampered with. Also related to that, there's authenticity, and distributed ledgers or blockchains have key pairs built in. And so this allows for the digital signature or the verification of who created and who modified the data. And you can add to that timestamp proof to establish when the data was stored. And this then leads to a chain of custody that enables data provenance. So you have this kind of like unlock moment of like from identifiers to authenticity to provenance. Moving to encryption and access control. And so similar, or basically what those key pairs allowed in terms of authenticity, they also allow for encryption. And so you can encrypt end-to-end data that is meant to remain private. Some of these systems are zero knowledge. And so that makes it that the storage provider has zero knowledge about the data being stored. This then allows for access control mechanism. So this can be done through smart contracts for programmable permissions and licensing. And so you can have access control lists, you can have time-based access controls, multi-signature authorization. This really allows for some flexibility in terms of permission and licensing. Moving on to data redundancy, availability, and I would add interoperability. So you have replication, so multiple copies are stored across different nodes. This can allow for some repair mechanism where some copies are lost, but it's still available elsewhere. And so there's this balancing of data retrieval. Back at content addressability, data is retrieved based on what it is, not where it is. And this removes single points of failure, improves censorship resistance. I already mentioned interoperability, but I'll do it again, where there's bridges between different storage network interfaces that can allow for data access across protocols. And that leads to some protocol agnostic data format. And finally, the privacy and security features. And you can bake in automated recovery procedures. This kind of is linked to the single point of failure that's removed. And then ownership and usage rights. Back at key pairs, this gives you a sovereign identity system, and you can have a proof of ownership and then have permission controls at a very granular level. This leads to enhanced data sovereignty, where users maintain control of their data, can choose where they locate it, and then this interoperability allows them to migrate between providers or self-host if that's an option, if that's preferred.
What are the benefits and opportunities for the GLAM sector? And I guess maybe a question is why to adopt any of this new and sometimes, frankly, slightly wonky technology? I'll go through the benefits that surfaced in the research that Rayco did last year. But for me, whenever I think about why any organization or institution might be interested in this, the key is, for me at least, is the creation and use of alternatives to mainstream options. If we don't envision and build other options than the current technical status quo, there will be no other options. And I think this is like a hard truth that like often these things, especially at first, don't work as well as we'd like them to, or they solve for one problem and create other problems. But I do think it's really key to keep in mind that without envisioning other types of technological futures, we will just have the one that a very small minority of people thinks we should have. That's my pitch. So benefits and opportunities. So these are divided into a couple of sections: economic advantages, infrastructure and environmental pieces, and art market. And I'll go through them one by one. So some of the benefits and opportunities as it pertains to the economic factors of using decentralized storage would be reduced overhead. So this is where the trustlessness of blockchains can come in. So there's automation built into smart contracts, which may make some things simpler. It also may make other things more complicated, but there is the potential here for reduced friction through the use of smart contracts, which are used on a blockchain. We can delve more into that if we want to. There's also the potential for revenue generation itself. As we've mentioned, if institutions want to run their own hardware and are interested in participating in a DPIN network, there would be revenue generation for that as well. Emerging markets. So Web3's created a number of arts and culture focused opportunities. So this is partly the NFT market that maybe some of you are familiar with, but it also goes beyond this. It includes things like retroactive public goods funding. So these are, I guess, campaigns or initiatives that offer funds to projects using cryptocurrency. The funds are using cryptocurrency to reward work that is perceived as being valuable to society or culture at large. Sometimes they're more traditional arts and culture projects. Sometimes they're more open source software projects. It varies depending on the type of retroactive public goods funding. Optimism ran one last year. This Optimism, the blockchain, ran one last year called We Love the Art, which was a fairly big initiative. We can pop the link in the chat as well if you're curious to see what that actually looks like in practice. There's also fund matching platforms like Gitcoin and Artisan. So these let people donate money, and then the platform uses a matching formula to boost the amount of money that is raised. Artisan is one that's focused primarily on arts and cultural initiatives of all types. The Node Archive was part of one of their recent rounds, but they support projects like really across the board, from music to, I don't know, gardening projects, like anything you can imagine that people contribute. And so the question here is, what are the opportunities for more traditional institutions to get involved in these types of initiatives? And what does it mean for them? And I think it's also important to note that there are a number of organizations that are already doing this, quite a few in Europe. There's an organization in Vienna. There's the ZKM Center for Arts and Media in Karlsruhe, Germany, the Whitney in New York, and Heck in Basel, Switzerland, all either have NFTs as part of their collection or are involved in the acquisition of an involvement in these newer markets as well. Financial inclusion. So Web3 has done away with some of the institutional gatekeeping. It does allow people, artists, creators to connect more directly with buyers. I think sort of the flip side of this is that there are some technical literacy skills required to use these tools. So I think it's like inclusion with the brackets around the technical literacy piece. Again, what are the opportunities for organizations to contribute to this? How can they be involved in these types of new exchanges? And then lastly, supply chain transparency. This can mean transparency around the provenance for NFTs, but this can also be applied to provenance around other types of digital media. As Vincent mentioned, there's a number of the technical attributes of these particular tools that you can use to trace the provenance, understand where things have come from. There is an interesting product called Numbers Protocol that people can check out if they want to see how this is applied to digital media other than NFTs. They have videos and digital images, like more traditional photographs, that use numbers to track the provenance. Yeah, thank you. Alrighty. So moving on to digital infrastructure and environmental benefits. As we've mentioned, decentralizing data improves its resiliency, and the model also reduces reliance on data centers. Why would we want to reduce the reliance on data centers? Don't blockchains use a huge amount of energy? We'll talk about that in just a minute. But just as a comparison point, a statistic I found is within, and I could only find it for the US. I would love to know if there's Canadian statistics for this type of thing. In the US, data center energy use accounted for 176 terawatt hours, which is 4.4% of all total electricity consumption in the US, or more than the total amount consumed by all households in California, which is, I think, there's 30 million people in California. So that's a pretty significant amount of energy from data centers. I think it's really important to hold this in our minds when we talk about energy consumption and the environmental effects of other types of decentralized and technology generally. Just because you aren't hearing about it doesn't mean that it isn't there. All right, as well, minimize physical hardware demand. In some cases, decentralized storage option can minimize hardware demands. Recently, there was, as with maybe some of you have been following, there's been a lot of chatter on the internet around the removal of content from the US government's websites. And there's an organization called Team Archive that has produced a product called Warrior that uses shared hardware resources. So it's essentially volunteer computing. If anybody was familiar with a program that ran for about 20 years called SETI at Home, which was similar, people donated like spare computing power to search for extraterrestrial life. I think the program folded about 4 years ago, or it's moved into a different phase, but it was always an interesting example of if you share your computing resources, then you are spreading the load. So talking again about energy efficiency. So that a lot of, as I'm sure many of you have heard, there are a lot of energy consumption concerns around the use of blockchain tools. The shift from proof of work, so that's one type of consensus mechanism, to proof of stake, which is another consensus mechanism, uses significantly less energy. A study by Cambridge found that when Ethereum transitioned between these two, they actually used 99.9988, so almost an entire shift around that amount of energy. The points in the last two ecosystem economic perspectives and the broader sustainability goals are a little bit overlapping in that decentralized storage presents an opportunity to take a holistic perspective on the infrastructure that we're using, rather than, as I mentioned earlier, just black boxing technology, which means that you don't really understand how it works or where it's coming from, but and thinking of it as being in the cloud or immaterial, to having a better sense of what is actually required to run this hardware, how you can care and maintain for it, what the energy consumptions are. As an example, and Jesse said 221A is interested in planning on running their own hardware. So then the energy for that hardware could be entirely powered by renewable energy. And just as an example, trying to find hosting companies that are run off entirely renewable energy is actually quite difficult. I think there's a organization in Montreal called Kumbit that I'm fairly certain uses entirely renewable energy, but it's not something that's top of mind for a lot of consumers. And so being more in touch with the hardware that you're running really does make it more real and can highlight the energy consumption uses for users. I'm just looking at the question in the chat. Yes, they use 99.8 less energy by using proof of stake. We can drop the link from the report in there. It was a study of Ethereum's energy use overall by Cambridge. All right, and there we go. Thanks, Ashley, for the tip on Kumbit. Lastly, around opportunities and benefits, and I really want to preface this by saying that a lot of these are forward-looking. Institutions can consider there's new ways for institutions to interact with artists and collectors. And I think this changes the power dynamics between organizations and institutions in ways that might be initially uncomfortable, but it's certainly better for organizations to be aware of these shifts and these aspects rather than just dismissing them entirely and hoping they're going to go away. Fractional ownership is an experiment that I wanted to highlight here. In 2021, an organization called Art Mundi paired with an institution to provide fractional ownership for a Picasso work. So you could buy a piece of Picasso, I think it was for like 50 euros or something, which I thought was interesting. And so this is one potential model that could be replicated and has been a few times. Royalties, so programmable royalty distributions. These were one of the original promises of the NFT, in that once you bought it, royalties would be distributed to the creator in perpetuity. Unfortunately, most marketplaces actually just bypass this, and the creators don't actually collect any royalties from it, which is unfortunate. And it would be nice to see some additional consumer demand around reinstating this. Maybe Vincent can weigh in here a little bit more if people have questions about that, because I know he's got some thoughts as an artist himself on the bypassing of this. But related to royalties, there's the concept of programmable splits. So this is where you pay your collaborators at the point of sale. And Meta Label, I would say, like publishing and cultural organization that put out a book called the Dark Forest Anthology on the internet. They published a really interesting retrospective just, I think, last week around how programmable splits enabled them to seamlessly work with, I think it was like 10 plus collaborators in a way that was pretty frictionless. So there's some interesting opportunities here as well. And the last point is around becoming a node as a player in the ecosystem. What does it mean for traditional institutions to go from considering themselves as being like a hub and having spokes to being more of an ecosystem, part of an ecosystem? And I think We Are Museums as an organization has done some interesting work in imagining like how this can evolve and transition. Of course, I would be remiss if we did not also talk about some of the challenges for the GLAM sector in adopting decentralized storage. In the research conducted last summer for the Node Archives project, survey respondents indicated quite a few concerns. The key obstacles included perceptions about adoption, environmental and ethical considerations, usability barriers, and a gap in skills and knowledge. I feel like we've highlighted the financial benefits of some of these things, but there was pretty widespread skepticism around the adoption of decentralized storage, which is why projects like the Node Archive we'll talk about, I think, are pretty critical so that people can take this from the theoretical into something that is a little bit more tangible for them. When we talked to respondents in the survey last year, the perceptions in the GLAM sector were that current systems were good enough, that there was a lot of mainstream hesitancy around the advancement and adoption of these tools. Other people noted that there are affordability and sustainability concerns for small organizations, suddenly having to like pivot or adopt the new technology. This is probably similar with any technology. And so this is again where my initial pitch around like envisioning different technological features comes in that like there would be challenges and costs to switching from another like SaaS provider as well. So it's just weighing some of these options. Other respondents felt that DLT based systems were just unnecessary. They didn't see the need for it, were inefficient or costly. And then, of course, as we've mentioned throughout, the environmental cost of blockchain tools was raised. There was also some ethical implications in terms of archivists who are approaching the immutability of, which essentially means that the information on a blockchain can't be changed. So from an archivist point of view, there were concerns around what if the information is wrong? What about dead naming people? Obviously, the way in which we term and frame things evolves. And if that information is reified, like how do you correct and address that? There are ways of doing that, but you would need to solve for those problems as you adopt these solutions. And then lastly, the technical skills and knowledge gap was pretty significant. 30% of respondents reported as having no familiarity with distributed ledger technology, and several just said they didn't know anything about it. So it's pretty crucial to recognize that these DLT-based solutions are still evolving. These concerns are very valid, and they're super helpful to bear into consideration as we move forward and talk about the types of solutions that we could propose, especially with things like the Node Archive. I think now I'm going to turn it over to Vincent for some discussion about more practical applications.
Yes. So you'll find a list of potential practical applications stemming out of these technological potential. You can have a look, read, but I'm interested in giving a concrete example of a project, a case study in decentralized storage. So just shared the link in the chat. It's the Rohingya project, and the Rohingya people have faced displacement, leading to approximately 3.5 million people living in a situation of state. And you can imagine such a situation creates challenges around cultural heritage preservation and documentation. And they've leveraged decentralized storage to create a digital archive that serves multiple crucial functions. And so there's one component that's identity preservation, and they have decentralized identity verification through blockchain-based systems, documentation of community membership, secure storage of personal records. This project also gave birth to a cultural heritage archive. And so the preservation of stories, oral histories, historical photographs, documents, cultural artifacts. And basically all that was technical implementation, blockchain-based identity, decentralized storage for tamper-resistant records. And from that even came education platform, its own coin for community incentives, and a cultural repository. A great example of a project that really leveraged the potential from decentralization, brings sovereignty and long-term preservation forward through these tools. And that's for that.
Okay, thanks, Gus. I'll take it just to talk about this piece. But yeah, on practical examples, we're thinking through where the ball is going, I think. So I just want to talk about this project. It's a pretty amazing example of people thinking about data sovereignty in terms, especially now in the AI landscape, because a lot of this decentralized storage work that's been going on over the past decade or more has been developed around around networking technologies, cryptographic technologies, blockchain technologies, all of that, but it wasn't necessarily designed for the AI landscape we have now, but it's actually turning out to be probably quite helpful in doing that. Because what comes up with all of that control over certain points of your data and control over access to that data is that larger question of governance, right? And so this data, the data that we're talking about in terms of these cultural archives, there's never one person making decisions about them, obviously. So this technology also allows for the distribution of decision making and the dissemination of dissemination of decision making across communities. And an example of that could be the Choral Data Trust. So was there a slide before that, Andi or Vincent, or was there just this one? Okay, no, okay, exactly. Let's go back to the first one. Yeah, that's one. So what the project we were talking about is when we opened with that image of the text that said all media is training data, that was actually an advertisement for this exhibition that was in London in the fall and winter at the Serpentine Galleries, if you know them, one of the largest public galleries in the UK. But they worked with two artists over the past couple of years, Holly Herndon and Matt Dryhurst, who are also known as musicians, to develop this piece called The Call. And it was developed by working with 15 choirs across the UK. And what they wanted to do was create a data set of choir music. And that data set can be used by AI model builders who are working to output audio. So the thing is, we have access through our institutions to probably some of the highest quality cultural data and cultural data producers in the world who have lived and who are living. And so what that means is we're able to create really high quality data sets for really specific AI outputs, which can be quite significant for cultural producers. And so what happened when these 15 choirs came together, they didn't all come together in the same space, but the artists traveled around the countries of the UK to visit with these choirs. And they recorded them very specifically to get the same kind of singing, or the same songs were singing, but in different styles from the different choirs. And the choirs were each encouraged to use their own distinct style. And so when you're thinking about the collection of cultural data and how it's going to be used eventually, probably in these AI data sets, that even went down to how the information was being recorded in the room. So they thought about this because when I talk about there's different cultural traditions that can also determine that data sovereignty as well. So when it comes to choir music, unbeknownst to me, but reading the white paper around this project revealed to me is that in choirs, soloists and chorists have different rights in terms of the production of that music. And so that was identified within the recording itself so that the soloist voices and the chorus voices could be captured distinctly and attributed distinctly to the artists who were producing those voices. It really developed a practical mechanism for a community-driven data set, because then you have 15 choirs who have to make decisions about how that data should be used after the fact. Andi, could you just flip to the next slide? And in doing that, and putting this data trust together around the choir recordings, so the key findings that came out of it is that they appointed an independent data steward to help facilitate community engagement amongst the choirs. That's an interesting role to play, to think about someone whose job it will be to make sure that the data rights and the creators' rights are being thought about at the point of creation, storage, and dissemination. So they created structured processes to gather and implement contributor preferences, and they developed a legal framework enabling collective rights management, establishing a governance model that balanced the artist, the institutional, and the community's interests. And in this case, community interest was both the music community and also the community who needs to work with these data sets to develop proper and well-trained AI models. So they balance those two varying interests as well. And so out of this project, the learnings that were really remarkable is that it just demonstrated a need for governance beyond individual opt-in and opt-out options. And so that's something we're hearing about with AI especially in the EU and the UK now, because they have legislation around it. It's not the best, but artists can opt in and opt out of model training. There are some drawbacks to that, but this project demonstrates that this governance potential allows us to go beyond just that simple just in or binary decision. It validated a cultural institution's potential as something called a trusted data intermediary. And I think that's a very interesting term that they've also written a white or kind of a concept paper around this term. So it is a call for cultural institutions, again, to stand up in this moment and say, we have the role and the social responsibility to do this, and we can become a trusted data intermediary. We can work with these data stewards and these technologists and these creators to come up with the best outcomes for what will be. So really, I think that's a very interesting role that 221A is interested in fulfilling. Like I mentioned, we're interested in hosting our own hardware, working with organizations and community groups to think about exactly these things. And so I've started using this term to talk about our work in the near future as we look to become also a trusted data intermediary. It highlighted the importance of dedicated resources for community engagement. So speaking to creators, working with artists, that work is so important right now, and we need to put so much effort into that. And working with folks like rights management groups across the media arts landscape, the visual arts landscape, writers groups, there's that. And I think these groups also need help in having those conversations about making some of those decisions too, because a lot of those groups are really stuck in copyright law. And that's the only framework they have to work within their tradition. But a lot of this technology is moving so fast that law and that legislation is not going to be enough to protect a lot of the creative data that we have in our institutions that it's coming out of artists. So yes, we need that legal work, and that's often slower and takes time for legislation to pass, but we also need to be working at the technology level with folks like Andi and Vincent, everyone at Hypha, and people developing these distributed storage networks to be coming up with alternatives to the status quo. And that's probably going to drive a better future for us, more so than relying on kind of 20th century copyright models right now. And this project provided a replicatable model for responsible AI development in the cultural sector. So it's a serious foothold. I have policymakers in Canada paying attention to this work because it's some of the most astounding work that we've come across. So exhibition's closed now, but the benefit is that it lives on as a data set. You can get this data set on Hugging Face, which is an AI data set repository that's like the GitHub of AI almost, if I can call it that. And these voices will be embedded in AI outputs for years, if not centuries to come. And it's a very real example of high quality data produced for those purposes. So this is the kind of use case that we could talk about. Why decentralized storage? Why do we need to have these kinds of networks? Why do we need to have these kinds of controls and decision-making powers? Because this is the kind of work that we're going to see coming out of artistic production and institutions hosting over the next decade or more. So we're for this kind of incoming practice. And pass it back over to you, and you could talk about the node library.
Sounds good. It is an interesting and very timely case study because I think it came out fairly recently. It's very exciting to connect it to the work that we're doing here. We're going to end by diving deeper into the Node archives, which is a project we've mentioned throughout the presentation. And this project really is setting up the software and the hardware elements for becoming that trusted data intermediary, as Jesse mentioned. So the Node archive aims to be a local first specialized storage system based on decentralized peer-to-peer networks and distributed or blockchain-based technology. It's part of the larger Node Library Initiative, which is a program initiative at 221A. And it's envisioned as combining archival-grade digital preservation tools with these blockchain-based technologies to enable secure storage and tracking of digital objects, but at the same time, adhering to archival standards without relying on centralized infrastructure like personal drives or commercial cloud storage. There are a number, as we've gone through, of digital storage solutions out there. What we're doing is marrying those solutions with an archive-first approach to ensure that we're covering the archival standards and specifications that need to be addressed already. The goals of the Node Archive project are low cost, user-friendly decentralized storage for GLAMS. The key really is to provide an on-ramp a Web3 on-ramp for cultural heritage professionals. As you've heard me discuss, there were some hesitations around what decentralized storage and its applicability to GLAMS and archives specifically. And as I mentioned, it does leverage these archival standards, and we'll explain how in just a moment, with the DLT's technology. And so the goal here is to create a prototype, a working prototype that GLAMS workers can play around with and understand if and how it meets the requirements, or how it does not, and work in an iterative process from there. So what did we find out? Last summer, we had the sort of set the landscape for the project through Reiko's research. We were very pleased to work with her and 221A on that. And what we surfaced was, through interviews with subject matter experts and the survey, were perceptions around DLT, some of these hesitations, get a better sense of what's been currently used, and just spend time understanding who is innovating in the space. The biggest issues that we found around existing solutions were cost, privacy, and security and usability. And decentralized tools addresses some, but not all of those, as we've mentioned. Around in Web3 generally, usability sometimes can be a challenge, but conversely, cost and privacy and security are something that these solutions actually offer an abundance of options for. And I think that brings me to the end of what I was going to say. Let me just flip ahead. Oh, sorry. And then I'm going to turn it over to Vincent. It is the end of what I was going to say, but Vincent can walk you through. So basically the research we did the survey, did the interviews with subject matter experts, and then at the end of that produced a technical brief in conjunction with Reiko and 221A. And this outlines the approach that we plan to take. And Vincent can talk to you about what that actually looks like and what I meant about the archival standards piece.
Thanks, Andi. And as Andi mentioned, this is part of the technical brief, a proposal for the implementation approach. And so after examining the landscape of the decentralized storage and understanding the technical components needed, we've designed this approach that combines traditional archival practices, such as the Open Archival Information System, with these decentralized technologies. And so this approach was specifically designed to serve the GLAM sector. And in my opinion, what makes this approach unique is its intent to bridge these established archival standards with these emerging storage protocols. And if we look at the technical stack, there's 3 key layers, each serving a specific function. And there's the foundation layer, which is Matica, which becomes the digital preservation system, and also process of ingesting digital assets and ensures long-term accessibility and preservation. Access to memory, the metadata management layer, manages all the needs for metadata, provides archival standard search capability, and then links metadata with content, and it enables cataloging. Then there's a distribution layer, and for this we're leveraging distributed press, which is a project incubated at a Hypha Worker Co-op. This project could be described as a decentralized content distribution system. And so it allows to publish content across the decentralized web to different protocols. And it allows to publish to multiple protocols. I mentioned IPFS already, but there's BitTorrent, Hypercore, and basically you could plug in any number of protocols, and then distributed press becomes this distribution layer. And so this distributed press then is the bridge between the system and these different protocols, which ensures content resilience and accessibility. This approach is we're taking a phased approach with different phases, building the basic infrastructure with IPFS and validating the specific needs in terms of metadata. Then there's this integration phase, implementing archival standards, adding the ownership layer, and so provenance, ownership tracking, access, licensing, then expanding to multiple protocols. And finally, we have the goal to introduce AI-assisted metadata management. Each of those phases builds on the previous one, ensuring we maintain standards and can build with these new emerging technologies. Next slide, please, Andi. And that last slide was the technical layer. Now let's look at the user journey of what a user would, the pathway for those users. So it's basically splits into two, what we've called a basic and advanced pathway. So whatever pathway the user will take, the journey begins when they log in and select their media asset. From this point on, there's this fork where they would go, if they choose the basic pathway, there's this simplified pre-selected metadata schema, and then a guidance to the submission information package, a streamlined archival information package, and then if I could summarize this option, it's basically perfect for new users or quick uploads. On the other end of the alternate pathway would bring much more flexibility in terms of metadata with different schema options or even custom schemas. The archivist would find their traditional submission information package process and could customize the settings. And this pathway would be designed for advanced users or experienced archivists. I guess the key takeaway here is the flexibility so that users can switch between pathway based on their needs. They're adapted to the user's expertise and prior knowledge. Both of them maintain archival standards while being accessible. And these are the two clear pathways for users.
Vincent, there's a question in the chat about what you meant by accessibility. I think it was around the phased approach. Did you want to tackle that before we go on to the last slide there?
Oh, I was talking about content accessibility, which is different. And that was in the context of distributed press and its use of different protocols. And the protocols themselves have this kind of redundancy that makes it accessible from different nodes or different storage providers. But then you can even push it further by using many protocols. And that's an example at Hypha when we use distributed press for our own website, for example. You can access it through HTTP, but also IPFS and Hypercore. And so the same content can be retrieved from different protocols. And so I think that's what I meant by accessibility. Is a synonym would be content availability. Any other questions? Did I miss others from the chat? That is also my slide. Yes. Okay, there's 4 key benefits on this page. We've touched on it through different ways, but cost savings, this automation through smart contract and autonomous execution can reduce overhead, elimination of intermediaries, and another way to save on costs. And then there's new models basically that allowed for new funding opportunities or new revenue streams. Enhanced preservation, so improved data integrity. We've touched on CIDs and their resistance to tampering. I've just mentioned redundancy and then long-term reliability. Improve access, so these networks being distributed brings accessibility, efficient data retrieval, and with that comes reduced downtime risk and better sharing capabilities. Finally, community control, and with regards to sovereignty and self-determination, that basically these values and applied to data management opens up community control, cultural sovereignty, and direct community ownership. And when you couple this with transparent governance, then you have the benefits of community control. Okay, we're talking about opportunities, benefits, but of course, I need to mention certain challenges and limitations. And we've mentioned environmental concerns, and there was this Andi black boxing, so giving visibility into it. The energy footprint would not be completely gone, but at least when you have ownership, you can have visibility into it. Mentioning this concern over energy consumption and the need for renewable solutions. Value alignment. So there is some tension with the traditional stewardship models. The community engagement piece that can be a challenging piece to tackle. And then the whole balancing technology with ethics. And finally, there's implementation challenge. So there's this, I've mentioned interoperability, but integrating these new systems with existing systems can be complicated. It requires resources, and there's always implementation challenges on that front.
Time. But yeah, just to give you a snapshot of where we're going, is it's that fair data kind of ecosystem is what we're looking at developing. So if you look on the left side, this is where I'm envisioning us going, but the node library and the storage prototype and node archives, we can provide some of that troubleshooting for the sector, we think. So there's infrastructure, there's compute capacity, there's storage, authentication, APIs, which allow our data to connect to different programs and softwares out there, and using the right protocols. Like that could all be under our hood. And what we could do is help connect our sector to this kind of data ecosystem that's developing. So yes, we need our own data trusts around these sorts of things. And so those could be one big or many smaller things dedicated to different disciplines. But essentially these are collective bargaining organizations, collecting organizations looking out for where their members' data is going and trying to go after those who are using it and under certain terms. So we could look at access controls, privacy rules, standards, usage rights, revenue distribution, and our ethics. So that's all under human coordination. We can make those decisions about our data. But what we also need to develop are automated layers for these things. And so that's where smart contracts come in. So smart contracts allow things just to be automated. Like an NFT was interesting in 2021 for one reason, but it's even more interesting now in 2025 for AI because it allows you to marry identity and transactional capacity around a piece of data. And so what that means is if that data goes into Sony Music's production pipeline, the Fire data trust, then there could be a rights payment that goes automatically back to the data trust because of that smart contract that could be attached to that piece of data in that training set. So what you need are those smart contracts, which are automated rights and access things around our data. And then we need AI agents. And AI agents are what's coming next in the AI space, but they're agents that are programmed to certain protocols to transact in a certain way, to make decisions on behalf of that agent's rightful owner, whether it be an organization, an individual artist, or whatever it is. But so those agents can work with smart contracts to do this negotiating. So there's not going to be people sitting at desks negotiating what data goes into Sony Music's pipeline. There will be smart contracts and AI agents doing this, but we have to have our data trust set up to make sure that the protocols around what those smart contracts and the agents are doing with our data are in agreement with us. And then once we can establish and build those pieces, that's when we can start to connect out to those training data sets and bring our data to public domain data spaces and proprietary data spaces, because that's important. That's an important role we can play as institutions. And those data sets will inform the kind of AI models that will come out. And there's different kinds of AI models, commercial models, academic models, public and open source models, local and community models. So that's the kind of ecosystem we're envisioning. If you're interested in building with us, join us next week. And also you can sign up to our newsletter too at 221A to get more information and get in touch with us to stay involved with that work. But I'll hand it over to Eli, who can close us down for this week.
Hey there, friends. First of all, just want to thank, both the Hypha and the 221A friends for hosting and bringing their deep expertise to this. Hi, I'm Eli. I'm at TechSoup, a nonprofit that helps other nonprofits, and we conspired with our colleagues here to help make this thing happen. This is actually all part of a larger initiative we're doing, which is an exploration into how can we help the GLAM sector really get their heads around what are these decentralized technologies and what do they mean. And so we've done a couple webinars, we've done a couple other events, and what we've learned is sometimes there's some real value in going deep, getting our hands dirty. And so we've created something called the Cultural Memory Lab, which is basically a space, a laboratory, if you would, where we can connect these artists, technologists, and cultural practitioners together to actually get to the point of saying, let's get real with some of these decentralized technologies. And so to do that, we created this lab, which is basically has a combined set of supports, which is there's a bit of technical mentorship. There's some education through our partners at Gray Area who've got their DWeb for Creatives course. We've got some coaching on basically building out your next bigger grant proposal, things like how to build out your budget and create your theory of change and project plan so you're ready to go to the next bigger foundation. And we've got a bit of a micro grant, something usually in the order of $3,000 to $5,000 US. And this is all for this sort of basically this 4-month overall engagement. Next, please. And so, yeah, so you come into this lab and once a week, learn a thing, start developing your ideas. And so the goal is at the end of this, you come out and you've got a great idea and a runway for how to take your project to the next level and experiment with some of these decentralized technologies and storage. It's currently open for nonprofits. Your team can be basically anywhere in the world. We can be anywhere between 1 to 5 people within that. And we're looking for people who have existing archives. So you've got something that you're ready to start digitizing or something that you're ready to start putting into decentralized storage, not exclusively probably, but as a way for you to experiment and learn through doing. Next slide. Now, when I said it's open, I was lying to you because we actually closed it back on February 2. But we are holding open a spot for a mid-process entry, and that's going to be exclusively for basically the people who have gone to these 6 events that we've been doing similar to this around the world. We just had last week some in Thailand. We've got some more planned for the Bay Area. And basically, if you registered for this event or the event we're holding next week, we will send you an email with your exclusive application opportunity to come and join the cohort at the mid-level, at the midpoint. And that will be probably starting in April. So that email would come to you by the end of March. So again, nothing you need to worry about right now, but what your email inbox is.
Any comments? Any reactions? If not, enjoy your afternoons. See you next time.
Amazing. Thanks everyone for your time.